Today's lecture is part 2 of chapter 7, retaining walls and lateral earth pressure. In the first part of the lecture, we finished all types of retaining walls and how they are constructed and how they are the concept of their design and so on. In this part of the lecture, we are going to study lateral earth pressure. Why we are going to study lateral earth pressure? Because in the last lecture, previous lecture, we found that to solve any retaining wall, we will need to study the forces coming from the water and the forces coming from the soil. And the forces coming from the soil are mainly lateral. So we need to study these lateral forces and to know how to apply them to be able to solve any retaining wall. So to do this, we have first to understand what is the problem that we have to solve. This is a shape of a retaining, this is a dam. A dam is something for retaining horizontal forces, something similar to the high dam in Egypt. In one side, water will rise maybe till it reach near the top of this dam, and in the other side it is dry. So there is horizontal force from one side, and this horizontal force is coming from water, similar to the horizontal force that will be coming from soil. The concept is that we have horizontal force. So here we managed to do this shape. This shape, there is a slope here in this direction, and there is another slope in the other direction. But of course, it consumed a lot of land. I don't have this luxury every time. Maybe in some situations, I cannot waste all of this space just to construct something to carry lateral force. So maybe I would need to have a wall instead of this. So last year we studied slope stability. This would be solved by slope stability problem. But if I need to replace it with a wall, then in this case I will have a different approach for the design. This is what we are going to study here. To study the lateral earth pressure, which means that suppose here instead of water you have filling, you have backfill reaching this road level. Then this backfill pushes horizontally. How much is this force that is pushing this structure? I have to calculate it. So to start, we start always with the previous theories that were proposed hundreds of years ago. There is something called Rankine theory. There is Coulomb theory. These are all scientists who proposed, or geotechnical specialists who proposed methods for solving this case. We are going to study now Rankine theory for lateral earth pressure. To understand this, we have to check this figure. Suppose you have this block of soil at a depth of h below ground. We all know what is the vertical stress on this block. Gamma h. This is h. This is gamma. So gamma h is the vertical stress. What is the horizontal stress? Is there a horizontal stress? This is the first question. Is there a horizontal stress coming from the vertical stress? Yes. What is the proof for that? The proof for that, as we said before, two practical proofs. If you see a weightlifter who is just carrying very heavy loads, you will find that he is putting a belt around his belly. Why? because he is afraid that his muscles would be torn away. Why? He's carrying vertical load. So what is the function of this belt? This belt is confining his body so that the vertical load would not have any horizontal effect on his muscles, and in this case his muscles would not be torn away. This is one thing. Other thing, you all know, in any column carrying vertical load, you put vertical bars. But why do you put stirrups? Don't tell me to keep the vertical reinforcement in place, because I could just put one at the bottom, one at the top, one in the middle, and this is enough. But why to put all of these stirrups? Because there are lots of horizontal stresses on the column. So it's the same. Here I have vertical stresses. So part of this vertical stresses will act as a horizontal stress. How to calculate this horizontal stress? It is the vertical stress, sigma V, multiplied by a factor. This factor is called K naught. Why do I call it K naught? Why naught? Because we call it at rest condition. What do I mean by at rest condition? At rest condition means that this block is not moving to the right, not moving to the left. It is in place, stable. So when it is stable and there is a vertical load, then this vertical load, part of it will be, or part of it will act horizontally. This part is equal to K naught sigma B. This is in case of at rest. But do I always have the case that the soil is at rest? No. Imagine that you have this wall. If you have a wall, what do you expect? With time, the wall is going to fall. This is especially if it is overloaded. It may be in few seconds it would move, and it may move after a month and so on. So there is expected motion. So in a retaining wall like this, if I have anything within this block, I call it the active zone. Why active zone? Because it is active. It will push the wall and take it down. So it is active. I have also another triangle here. This triangle, it has no place to go. But because of the pressure of the active zone, it will be compressed. So it is another type of motion. It's not an active motion, it's a passive motion. Somebody staying at his place and somebody else is pushing him, so he is confined, or not somebody, maybe two persons, one from one side and one from the other side, he will feel compressed. So this is what will happen to this passive zone. So it is passive. Passive, it means that no this block did not exert any effort. He was just receiving the effort of another zone. So passive means that he is not, or it is not doing something but receiving. Therefore, the active zone is the zone that is expected to move. And the zone that is expected to move towards the wall is the strongest or the stronger zone. If I compare this zone to this one, the height here is more. So I expect that because of the increased height here, then this will be the active zone and this will be the passive zone. Because imagine for yourself, can you draw this dotted line at the other side? You won't feel it. You will feel that, how come? You will tell me, how is this possible? This small height would push the wall. No, the more expected is that this big height will push the wall. So this is the active and this is the passive. So this equation will change, because in this equation we said that sigma horizontal is equal to K naught multiplied by sigma vertical. K naught is a constant for the at rest condition. Then I have to have two other constants, Ka, which is K active, and Kp, which is K passive. A constant for the active case and a constant for the passive case, because of course the percentage of the vertical load that will be horizontal will change according to the direction of motion. If I take this square here, this sigma vertical, you will find that any block here will be affected, or any small block here will be affected by something called K active multiplied by sigma vertical. In the opposite side, it will be K passive by sigma vertical. Just to understand the difference between K active and K passive, I here understood what is K naught. K naught is something at rest, but I have here K active and K passive. Which is bigger, and how much is it bigger? This chart just for indication. Here is the value of K at this axis. This point is a simulation for K naught at rest. Here is K active and here is K passive. It means that first, K active is less than K naught. This is the first thing, because let me take it this way to understand it. This is a vertical force. Part of the vertical force will act here. Suppose that I tried to move the block of soil. I mean, the confining pressure is reduced. Confining pressure means this force. Imagine that this force is 0, and I have a force here. Of course, once this block start to move, the amount of the force will be reduced. If somebody is pushing you, and you are standing still, you will feel all the force. But if you just move a little bit opposite direction, you will feel part of his force. So this is what do I mean by K active is less than K naught. Why it is less than K naught? Because this block started to move. So he started to relieve part of the force that is affecting it. So K active is less a little bit than K naught. Now the opposite. Suppose I have here, this is the vertical force, and instead of motion in my direction, or away, I mean in the direction of the acting force, of the acting horizontal force, the body started to move in the opposite direction. You are standing and somebody is pushing you. Instead of you going away, you started going in the same direction, as if you are increasing the force on your side. So it will be more. So K passive will be more. But to have adequate passive force, here, there is some motion, but I said here that this bulk wants to move. Now this bulk will be affected by this other bulk. Usually, the passive force is much higher than the active force. If you want to think of it in case of aggression and defending. If somebody wants to occupy others' land, he will go to occupy the land of the other. He may be strong, but he will try to prove that he is strong. But people who own the land are always much stronger. Why they are much stronger? Because they are in place. They did not move. They don't have to, they only have to defend their land. So think of this to understand it, that this is trying to occupy this land. So what will happen? You will find that people living here are very, very strong and very tough. Why they are very tough? Because they are in their place, and somebody is trying to occupy part of their land. So they are very, very strong. So this chart shows you how much K passive is stronger than K naught. This is K naught. K naught is the at rest. This is K active. It is less than the at rest, but K passive, it can reach more till maybe 6 times the K active. This is just to remember. This figure is just to try to understand the value of K active and the value of K passive. This just for discussion. But if we want to calculate it, then we will calculate it here and we will come to it again. But before we calculate, we will just study, we said that we are going to study Rankine theory. Before you study any theory, you need to understand the assumptions of this scientist, because he assumed something and proposed an equation. Before using the equation, you should be sure that this equation is applicable to your case. Maybe he assumed something that is completely different than your case, so you cannot use it. So, first of all, he assumed that the soil is elastic. Most of the theories, especially the old theories, assume that soil is elastic. Homogeneous, of course, because he cannot assume that the C and phi will change in the top layer and in the bottom layer. It is difficult for them to assume something like this. So it is homogeneous. Isotropic. Isotropic means that the forces in all directions are the same, similar to water. Water is isotropic. If I have at a point and I calculate gamma water by H, this gamma water is acting in all directions. It does not affect, there is no, it cannot be more in the right than the left. It is always the same. But soil is not like this. Soil is different. But the assumption of Rankine that it is isotropic, it is similar to water. The stresses in all directions are the same. He cannot, and it is half space. Ignore this half space. Half space means that I'm not studying something, all of it in the soil. No, I'm studying part soil and part air. So it's not important for us now, but you just know that it is half space, and half space means that I have soil and I have the space above the soil, so they are both presented in this problem. If I have a retaining wall, this is half space. Here is soil, here is air, so it is a half space. These are the first assumption. Second assumption, the wall surface is smooth and vertical. This is very important. The wall is vertical. You may have a retaining wall with a sloping side. This equation cannot be applied. It can be applied with some approximation, but to apply it correctly, no, it cannot be applied. And it is smooth. Maybe in some cases, if I have a rough wall, no, a rough wall would have different behavior. So it is smooth, vertical, The wall can move and exert active and passive earth pressure. Of course, this is normal. The wall can move. There is nothing that is preventing the wall from motion. It can move as it wishes. The ground surface is plane and horizontal. This is also important. Here, the ground surface is plane and horizontal. In some cases, you may have the ground surface going like this, sloping, or in this, it is like this, or it is like this. I cannot solve this problem with Rankine theory. The soil is phi soil. This is the most important. The soil is phi soil. It means that I cannot use this equation to solve a retaining wall carrying sea soil. If you have clay and you have a retaining wall in front of this clay, you cannot use this equation because it should be a phi soil, or in the worst condition a sea phi soil. It means that there is sea, but the main constituent is phi. So this is very, very important, and you will know why when you see the equation. No external loads are acting on the ground surface. Extremely important thing, because if you have on top here, you have a building, you cannot solve it. This equation will not take into consideration that you have buildings on top of your soil. If you have buildings, then you have to think of another approach for the design. So these are very, very important. If you don't know these, understand it, not memorize it, understand it. From this, what are the very important things? No external forces, phi soil, the soil is horizontal. This is, of course, it goes without saying. The wall is vertical and smooth. These are things that may change from equation to the other, so you have to know them by heart. What is the equation given by Rankine? Let me just put something so that we can compare each time. I'll just put a drawing so that you can compare the equation to it. Here, the first equation given by Rankine theory is that K active equal K active, sigma active, which is the active stress, the active horizontal stress, equal K active multiplied by sigma vertical. This will happen here. This is the active zone and this is the vertical stress. So the active, this is the equation of the active horizontal stress. We have passive horizontal and active horizontal. So the active horizontal stress is the vertical stress multiplied by K active. So this is the main equation. But to calculate this, I need, what did this theory gave me? It gave me the value of K active. So K active, which is the coefficient of active earth pressure, is equal to 1 minus sine phi divided by 1 plus sine phi. So here you find that we are dealing with phi. That's why we said it is phi soil. I'm not using C, it's just phi soil. So 1 minus sine phi divided by 1 plus sine phi. So I take the phi of the soil, substitute in this equation, I will get K active, multiply K active by the vertical stress, I will know the horizontal stress. So this is very, very easy. The other equation is for passive. The equation for passive is sigma passive equal K passive multiplied by sigma vertical. This will be in this side. This is sigma vertical. This is sigma passive. So sigma passive, it will be equal to K passive multiplied by the value of the sigma vertical. What is the value of K passive? Compare it to K active. K active was 1 minus sine phi plus 1 plus sine phi. Here there is something wrong in this equation. We have to check it. The wrong thing here is that in this it is K passive, it will be equal to 1 plus sine phi divided by 1 minus sine phi, because K passive will be equal to 1 divided by K active. So if I have here, say I have K active, say the value of it is 1/3, in this case here it will be 3. So 1/3 compared to 3, it's something like 9 times the value. So this is K passive is the opposite. I have to modify this in my slide. So now I need to get the full equation. Suppose, as we said, that the equation is working mainly for C soil, but I mean for phi soil. But it may work for C phi soil. There may be an effect for C, but this effect of C would be something less than the effect of phi. But if I have C soil alone, I can't work with this equation. So in case of C phi soil, then my equation will change, and let's compare both equations. So we can say that this is the general equation in case of C phi soil. What is the general equation in case of C phi soil? K active is, not K active, sigma active. We said before that sigma active is K active multiplied by the vertical stress. Here it is K active multiplied by the vertical stress. This was for the effect of phi. But what is the effect of C? The effect of C is minus 2C root K active. And sigma passive is the same, but plus 2C root K passive. So you see here that in the equation I have a minus sign. Because I have a minus sign in the active direction, it means that the effect of C is reducing the horizontal force, not increasing the horizontal force. The effect of phi is always pushing the wall. So this equation can apply, the effect of phi can apply. But if I have part of C soil, so it will reduce the active force. In this equation, you have this part is the effect of the phi. Here, the effect of C. The effect of phi is positive, but the effect of C is negative. So because you have a negative effect of C, so it reduces the value of the effect of phi. It means that in some cases, maybe I would have this term equal to this term, and it would be 0. The final is 0. Suppose I tell you solve this, use Rankine theory for, instead of C phi soil, use it for C soil only. If I have phi equals 0, then it means that this term will be neglected. So I will have only a negative term. A negative term means what? Means I don't have earth pressure. Instead of earth pressure, it is as if the soil is pulling the wall, and this is not possible. The soil is pulling itself, but it cannot pull the wall. So to apply it with, if I have only C and I want to apply this equation, I will find that the C will pull each other, but once it reaches the wall, it will leave the wall, and there will be a separation between the soil and the wall. You know that this happens, of course. Why? How this happens? When you go to any field and you find that this field was not irrigated since a very long time, what you will find? Cracks. What are these cracks? These are the minus sign, the effect of the sea. It's the minus sign. Soil separates from each other. So if soil separates from itself, would it take the wall to its side? No, it will leave the wall. Go to your work, and I will go to my work. I have things to do. So that's why I told you that you cannot use this equation for a sea soil, because you don't have a problem. If you have a sea soil, it means that from top to bottom there will be a full separation between the soil and the wall. But if I have both, if I have sea and phi, it means that phi will have an effect. Let's go back to the effect of phi. You remember this? You remember what is the effect of phi? We usually say that phi is function in gamma h. What is the value of gamma h at this point? 0. But what is the value of c at this point? It's a value. So if I use this equation at ground level, so this term will be equal to 0. But this term will have a value. It means that starting from the top of the wall, there will be a separation, because I have a negative earth pressure. So it means that the soil is retreating back. But if I go a little bit below, in this case, I will have a small value for gamma h. Still, I did not reach this negative value, but I started to have a small value of gamma h. So as I go down, the crack will be smaller till I reach a point where this positive value equals to this negative value. In this case, the soil returned back and touched the wall. So there is a triangular crack on top. So if I have a C5 soil, it means that I will have a separation on top, and then this separation will close till it reaches 0, and once it reaches 0, it starts to push the wall. So in this case, so my earth pressure starts from this point. If I don't have phi, then I will never reach this point. I will always have a separation from top to bottom, and this separation will be constant. If this separation is 2 centimeters, it means that the soil, the clay will leave the wall and will be separated 2 centimeters from top to bottom, so I don't have a case to solve. So this is, as we said, this is the equation for sea soil. This is the equation for phi soil. And we said that here also, obviously, that the modification was not done for both slides, so we have to modify both slides. We said that the K passive is 1 over K active. So if K active is 1 minus sine phi divided by 1 plus sine phi, so K passive will be the opposite of it. This is what we were discussing now. We said that if I have a C5 soil, it means that there will be a separation. So if I go at the point at the top, what is the pressure of the soil on the wall? We said that it will be a negative value. Negative value, just draw this dotted line to represent this negative value. Once you go down a little bit, you will start to have an effect for phi. Phi will be added to the equation here. When you go down, you will start to have more earth pressure. So once you have more earth pressure, it means that this negative value will be reduced till I reach a level where the negative part equals the horizontal, the positive part. In this case, here will be 0. Once I reach this 0, I go down till the end of the wall. All of this is positive. So if I tell you what is the earth pressure on this wall, you cannot tell me that the earth pressure starts from this point. No, this point is supposed to be not a pressure, it is a tension, but of course we cannot have a tension, so we ignore this dotted triangle, and we start considering our triangle from this point till the end. This is our earth pressure or representation for the earth, for the passive earth pressure. So the passive earth pressure is only this triangle. How can I calculate this depth? You have many approaches to calculate this depth. You just apply the equation at this point, apply the equation at this point, you will get this value and this value, draw this line, use any mathematical way or graphical way to calculate this depth. We call it H crack. H crack is the depth of the tension crack that will be induced in this soil due to the effect of C next to the phi portion of the soil. Here is don't consider that these are equations that you need to memorize. No, don't memorize. I just need to calculate this depth, calculated graphically, calculated using equation, calculated whatever. This is an equation. H crack equal to C divided by gamma multiplied by root K active. But I don't need this. I have an equation. I can substitute in this equation at this point, and I have another equation I can substitute in this point, and I can just get this point, make an equation. Say that here, where is the equation itself? I want to have here. I want to have the point where sigma equal to 0. So it means that it is the location where 2c root k active equals k active multiplied by gamma vertical. You will find that the only factor that you don't know is sigma vertical, because it is K active multiplied by H, and you don't know this H. This is H crack that we need. So just substitute, remove sigma vertical and make it gamma H crack. And then solve this equation, you will get H crack. Whatever the way you are going to use it to calculate H crack, calculate it. Why it is important? Think of it for a while and then tell me. This is how we can solve it using trigonometry. Solve it by ratios and something like this. So you can solve it by equations, you can solve it by drawing, you can solve it by trigonometry, solve it by whatever you want to get H crack. But why do we need H crack? I will just go this to this figure. What's the importance of H crack? You will tell me that H crack, because starting from this point, you will have an earth pressure here. It's not starting from the top. Yes, this is, but there is another thing which is very, very important. In many cases, suppose that you have rain. Water will fill the crack. If water fills a crack, we said that water is isotropic. The stress in water in any direction is the same. So if I have a lake of water with a depth of meter, it will give a horizontal pressure similar to a tube of water with a depth of 1 meter. What is important is gamma H. Gamma of water multiplied by H. This is the vertical. It means that this is the horizontal. In water, it is the same. In water, sigma active, sigma passive, sigma naught, all of them equal to 1. It means that sigma vertical is the same as sigma horizontal in all directions. So in this case, if I have a small crack here, and this crack is full of water, you will have here a triangle. I will just go to the figure here. This is the crack, and this is where the water, the earth pressure will start. But from this point to this point, I should add here a triangle showing the pressure of water. This is important, because it is not that I'm neglecting the earth pressure. No, I'm neglecting the earth pressure and replacing it with a triangle for water. Of course, in some cases you may be asked to solve a problem neglecting the edge crack, or neglecting the effect of the earth edge crack in case of water filling this edge crack. It depends on the problem, but this is normal life. Normal life, if I have a crack, then I have to assume that it is full of water. يعني just we can just stop here and continue after a while.